All right, so here are the even number questions for modeling with sine. So you're given a table of values. This will not fit perfectly into a sine model. We're going to have to do like a curve of best fit and try to do our best to fit an equation to the model. No, it's not going to be perfect. All right, so what do we need to know? What information from here is going to be helpful? So I need to know the minimum, the bottom of my wave. So I see 29.6, I see 32.5 on the other side. I'm going to find a nice number that allows me to use both of them if I need to. So I'm just going to round it and pick a nice number and use 31 as my minimum. Kind of like a line of regression. There we go. Then I need a maximum number for it, so I can clearly see that it goes up to 85. Then, using the minimum and the maximum, I can then find the middle. So to find the middle, I'm going to add them together and then divide by 2. Like finding the average between 31 and 85. So what is that? Let me use my calculator. It's like 116. So the middle of my graph is going to be 58. Next, if I want to understand this equation, I'm actually going to use a factored form of this equation. So it's going to be y equals a sine b x minus h plus k. So I'm going to use those instead of the Greek letters. If I want to understand b, I need to understand that's going to be 2 pi divided by whatever the period is. So we have 12 months. So the period is 12. That's how long it takes to complete a cycle. So I'm just going to plug 12 in. I don't have to reduce it down. I could reduce it down to pi over 6. The last thing I need to understand is my h, the phase shift for sine. So this table of values starts at the bottom of the wave. That's cosine. If I want to start with sine, I need to find where the middle of the wave is and then shift it over to the middle so I can do that. So if I understand it's bottom to the top to the bottom, I need to find the middle to know where to shift it to the right. So if we have 12 months and I break it up and understand we have 1, 6, and 12, those are my bottom, top, and bottom again. Here is going to be where the middle of my wave is going to be. So we have 1 and 6 and 12. In fact, the middle of my wave, I probably didn't correct it. If I'm going to go 1 through 12, then yeah, 6 would be in the middle. And if I'm going to break it up even further, this 3 and 9 would be in the middle of my wave. So I need to know my shift needs to go over to the right 3. And my k is the middle of my wave, which we just said was 58. So we're going to use those numbers to estimate. So the top of my wave, the amplitude, I'm going to take the top of my wave and subtract 58. The top, subtract the middle, and 85 take away 58. So my amplitude is 27. So we have an amplitude of 27. Inside will be 2 pi over 12, x minus 3 plus 58. Using this function, estimate the temperature on September 15th. So September is the 9th month, and 15 is halfway through. So it'd be 9.5. So I'm going to use my calculator. And then calculate it. Now it needs to be in radians when I do this. And I get an approximate answer of 51.01. And again, we're trying to model it with a smooth wave. So when you look at September and October, you have to try to understand that these maximum numbers, right, aren't going to make a perfect wave in terms of where that is. So we're trying to do our best to model it and then use that model to try to be able to see what we can do with it. All right, turn the page. Number 4. So in number 4, it says the data below represents the average monthly cost of natural gas in a home. And then it says, above is the graph of y equals 45.05 sine x, superimposed over that scattergram of the data. Find the sine function of this form, and we're going to do it in this form, where we do it in a form where we have HK, which best fits the data. So we are already given this idea that the amplitude is 45.05. But now we need to find some other information. So I need to know the max of this wave. And so I'm going to use as a maximum, and it's what? In like February or March, right? So February is 111. So I'm going to use my maximum to be 111. The bottom of my wave, so if I use 45.05, I'm going to subtract that from 111. Or I'm sorry, I'm going to find the middle of my wave. So let me find the middle of my wave first. So 111 subtract 45.05. So the middle of the wave is that. Subtract 45.05 again. And you get 20.09 being the bottom. And that seems reasonable because the bottom here is 21.2, so we're not that far off using that model. So what else do I need to know that I don't know yet? I need to know the period, how long it takes to complete a cycle. So it's 12 months, so the full cycle is 12. And now we can plug in. So the equation is going to be 45.05 sine, and then it's 2 pi over 12, and then it's going to be x minus. Now if I'm going to shift it over, I need to get a sense where the middle of the wave is. So again, it's the idea of 12 months, and we start at the bottom. So I need to shift this over 3 months so it's in the middle of the wave and then going up. And then the midpoint, or the K, and we said that is, the middle is 65.95. So what we want to do is be able to model this part of the wave, right? And we're starting with this, and we're shifting it over so we can match. So notice the middle of the wave here is 3 months over. So I need to shift it over 3 months so we can start in the middle of the wave. All right, turn the page. Number 6. Again, we have a table of values. It's not going to be perfect. So let's start with the scattergram to begin with. So the scattergram each month is obviously can be represented by a number. So we're going to do 1 full year. And then on the axes, just have an understanding of what we're doing. So our lowest number in all of this is 49.6. And our maximum number is 66. So think of what scale we would need to use here. So if I counted by 5s, 1, 2, 3, 4, 5, 6, 7, 8, 9, no, just 9. So I'm going to count by 10s. And then January is 49.6. Put a little X there. 50.8, almost the same. 3, 55, it goes up a little bit. 4, 58-ish, goes up just a little bit. 5, 60. 6, 63. 7, 66. 8, pretty well the same. 9, 64, pretty well the same. 10, 62, it does drop down just a little bit. 11, 54, drops down. And then 12, down to 50. Okay, so there's my wave that starts at the bottom, peaks, and then goes back down again. So what information do I need to get from this? So I need to know the max in the middle. That'd be a good place to start. So the top of the wave, what would be a good number for the maximum value? And I think 65 seems to be a good number, or 66. The bottom of the wave, a good number looks to be about 50 for the minimum value. That's looking off the table of values. And I'm just using a whole number. So using those numbers, oops, that's the minimum. Using those numbers, could you add them together and divide by 2 to find the middle of your wave? So that's 116, right? So the middle of the wave would be about 58. To find the amplitude, take either one, the top or the bottom, and subtract 58. So in this case, the amplitude is 8. It goes up 8 and down 8. That's the amplitude from the middle. What else do I need to know? The period. So the period is 12 months, so it's 12. And then the last thing I need to know is the phase shift. So since it starts at the bottom, and again 12 months, we need to shift it to the right, a phase shift to the right, to be in the middle of our wave going up for a sine, because sine starts in the middle. All right, so it's y equals, the amplitude is 8, sine, then it's 2 pi over the period, and then it's x minus 3 plus the middle of the wave, which is 58. So this is also your k in your equation. So if you wanted to use this function to estimate the temperature on June 12th, so June 12th is the 6th month, and there are 30 days, so it's 12 over 30. So I'll just use my calculator. I could plug that in, but it'd be easier if it was a decimal. So as a decimal, 12 over 30 is 0.4. So that's the same as 6.4. So to do this, I'm going to go 6.4, and I'm going to go 8 sine 2 pi over 12. 6.4, take away 3, plus 58. Here we go. So I'm going to type it in. And I get an approximate answer of 65.8. as an approximate temperature in June using this model. And I can look at my table of values and see if that looks reasonable, and it does. In terms of that could be using the model, that would be a good estimate for the temperature. All right, number 8. Oh, there is no number 8. That's it. So there's your homework about modeling using the sine function. So good job doing your homework, Mr. GMAT. Over now.